All right, guys, thank you for joining. Myself, Zahid Bashir. I am a PhD scholar at Halle College of Commerce, University of Punjab, and faculty member at the Department of Commerce, University of Gujarat. So, today our training session of Stata comprised of basically the quartile regression, which is an important consideration towards the panel regression modeling. There are three types of regression models that we can utilize with panel data modeling, along with the static model and dynamic model. We can also consider the quartile regression in panel data modeling. So, first of all, I would like to discuss this theoretical consideration regarding the quartile regression. I have selected a paper that I would like to discuss here in order to have the theoretical grounding of how the novel panel quartile regression will be used. On our session on Monday, I will discuss its advanced form, that is MMQR, that is method of movement with quartile regression. I will discuss on Monday. So today I will discuss how quartile regression will be used and what is the theoretical reasoning why we use quartile regression and in what circumstances this regression modeling is basically applicable in your case. You cannot apply uh, quartile regression unless until you fulfill some certain assumptions. So first of all, you need to understand panel quartile regression, its theoretical grounding, and what is the purpose of panel quartile regression. So in this paper, they have used panel quartile regression analysis to examine the relationship between renewable energy consumption, broad money, urbanization, and natural resources, and their effect on carbon emission and economic development. If you see here, they have a number of independent variable. For example, renewable energy consumption is their independent variable. Broad money is their independent variable. Urbanization is their independent variable. Natural resources is their independent variable. So they have used one, two, three, four, and five independent variable, and they would like to see their effect on two dependent variable, carbon emissions and economic development. So there are two dependent variable and five are independent variable. They have used fixed effect panel quartile regression analysis in order to adjust for geographic variability, because we have a number of countries from South Asian SAARC region. In this way, we have to consider the geographical variability because there is a variation of estimates of effects in different countries due to their unique geographical variations. So we need to understand its theoretical underpinning regarding why this method was used and what is the detail of this method. First of all, we need to see how many time period they have used. They have used a 30 years time period here from 1990 to 2019, a 30 years time period. And it is basically a panel data, but they have used 30 years time period. And if we see, they have also utilized fixed effect, random effect as a static panel model in order to see the robustness of their results. Because if the final model is quartile regression, they might have used fixed effect and random effect as a robustness of their model. So from here, the econometric modeling starts. From here, you need to understand why they have applied this specific model. So first of all, they have checked the cross-sectional dependency. I have told you that in order to check the cross-sectional dependency, you need to use a specific test by Pasran, whether there is a cross-sectional dependency in your model or not. So this model seems to be a long time series panel model, because here the number of years are too much high as compared to number of countries, because I believe that there are 5 to 6 countries here They may have mentioned at somewhere that they have used 5 to 6 countries data, and number of time periods are 30. So here T is greater than N. So I will let you indicate where it is written. So the first thing they have estimated here is cross-sectional dependency. So we already know the procedure of how to test the cross-sectional dependency here. Then what they have done, uh, after checking the cross-sectional dependency, they have provided their reason that this means there is a evidence to suggest that there is cross-sectional dependency in the data. So the first thing they have considered that there should be a cross-sectional dependency in your data in order to apply the panel quartile regression. So there should be a cross-sectional dependency in your data. If you could not found a cross-sectional dependency, you cannot apply the panel quartile regression. It may be necessary to use methods that accounts for cross-sectional dependency. So they have provided the reason that the panel quartile regression basically is the solution for cross-sectional dependency. Then they have also applied the panel unit root test, as I have already mentioned that if cross-sectional dependency is found in your model, you need to apply the first generation unit root testing that we have used. The first generation unit root test includes IPS and Niven-Lin-Chu and Fisher type test. So these tests are simply to carry out perform well with small samples, because here the number of countries are very small, while the number of time periods is very large. But they have also mentioned that they have considered the second generation unit root test. But in this case, if cross-sectional dependency is found, we don't need to consider both generation of the test. If we see here, I have mentioned, I need to show you something from here, because when I have considered the framework of panel data, if cross-sectional dependency is found, you need to apply the second generation unit root test. But if the cross-sectional dependency is not found, then you need to apply the first generation. So in this paper, they have applied the first generation as well as second generation, although the second generation was only required here as a panel unit root test. So this is the basically basic modeling, the basic panel data modeling in order to consider the panel data set. Uh, from the OLS, they have started their model like GDP as a dependent variable, REC, NR, BM, and UR as a independent variable. As I have already mentioned that they have two dependent variables, GDP and CO2. These are two dependent variables, GDP and CO2, while independent variable are same, REC there and there, NR, BM, UR. So you have seen the same set of independent variable while there are two dependent variable. Then they applied the one-way fixed effect, the two-way fixed effect in their modeling. Then they have considered the simultaneous quantile regression. I will let you know what is simultaneous quantile regression, because I have created a file, a Word file that will let you know the step-by-step procedure, that how to consider the quantile regression, how to consider the simultaneous quantile regression, and how to consider the panel quantile regression. So I will let you know. But theoretically, you need to understand what are these. So simultaneous quantile regression, this method is useful when there is interest in examining the relationship between multiple dependent variable and a set of independent variable. So why this model is applied? This model is applied when you have more than one dependent variable and you have a set of same independent variable that you need to see here, because in this case they have two dependent variable and a set of independent variables. And the thing that they have discussed, this is the model that they have applied to account for potential heterogeneity across different SARC countries. We also estimate the model using one-way fixed effect. So they have considered a fixed effect in their model. And after that, they have also considered the two-way fixed effect in their model. And then they have provided the result. So let me show you the result of this regression, and then we will start our estimates using Stata. This is the first generation unit root test. This is the OLS one-way fixed effect estimates. You can see here the pooled OLS, the one-way fixed effect, the two-way fixed effect model. One-way fixed effect means that there is either the cross-sectional effect or either the time series effect. But two-way effect means that you might have the time series effect as well as cross-sectional effect at the same time. So they have considered it here. You can also see the cross-sectional dependency test here, and the values indicate that there is a cross-sectional dependency in the model. So always remember, if the value of cross-sectional dependency is significant or less than 5%, it means there is a cross-sectional dependency in the model. In that case, you need to apply only the second generation unit root test. And if you see here, in case of second generation unit root test, all the results are significant. It means data is stationary. Data is not non-stationary. Data is stationary here. And now we would like to see the quantile regression result. Here, I think there is a question from, all right, press full screen. Let me open the full screen. But if we enter the full screen, it will decrease the size of the document. So what is your suggestion? Should we consider the full screen? Because full screen basically indicate a lesser size. And is it visible now? Is it better? Please indicate me, Adnan Afzal. Is it better now?
Yes, better now.
All right, because full screen basically decreases the size of the document, and it shows us the full page of the document, but we need the specific part. So this is the quantile regression result. If you see here, there are quantiles at 10%, at 20%, at 30%, at 40%, at 50%. Now, let me tell you why quantile regression is basically used. Sometimes we are interested in a specific median or specific part or specific quantile of the regression result. Sometimes the regression result that is based on the mean value is not providing us a significant estimate at the mean. So we need to see whether at some quartile, at 10% quartile, 20% quartile, 30 or 40 or 50% quartile. Always remember that 50% quartile is basically the interquartile range. It is the half of the value, while 75% is the third quartile and 25% is the first quartile. So always remember that sometimes the values which are not significant with simple regression analysis, they might indicate a specific quartile range where the values become significant. So if you see here, the REC, the NR, the BM, the UR, they are basically the independent variable, while GDP is their dependent variable. In this case, the GDP becomes the independent variable, and they have considered the second variable, that was CO2 emission, as a dependent variable. So you can see here that at first quartile, REC is negative but not significant. But at second quartile, it is negative and highly significant. At third quartile, at 30% quartile, it is also significant. At 5%, at 40% quartile, it is highly significant. So you can find out at which quartile a particular variable is highly significant and in which quartile it is not significant at all. So what we can conclude here that renewable energy consumption, it is not significant at 10%. It is not significant at 60% quartile. But if we see the highest value here, along with the significance, is at 40% quartile, while it is also significant at 90% quartile and 20% quartile, and it is significant at 5% at 30% quartile. It is weakly significant at 50% quartile. In the same way, you can also see the NR, at which quartile it is highly significant. We can find out almost 40%. At 40%, it is highly and significantly impacting the dependent variable. So this is how we can generate the quartile regression. So this is the first table. The second table will indicate you like this. This is another quartile, simultaneous quartile regression. So how they have generated these results? In order to understand the whole procedure, you need to understand the quartile regression one by one. So let me open a file from here. Let me open the Stata and let me show you how to use the quartile regression. So if quartile regression does not work in your Stata program, you just need to install it using SSC install QREG. The command is basically QREG. So QREG is quartile regression command. So you need to install it. I have already installed it, so I don't need to install it. But if the command does not work in your uh, software, you need to install it first. So let me open a specific data set. Let's suppose I have a lot of data set. Let me open, let's suppose the low income economies, and let me drop the selected variable like this. So how to consider a QREG command? Always remember that simple QREG is not a panel data command. The panel data command is XTQREG. This is the panel data command. Before running the panel data command, you need to understand the simple QREG or quantile regression command. So what we need to do, the procedure is simple. QREG DVs and IVs. That is the command. So we need to write here QREG, and then we need to put here dependent variable and independent variable one by one. Now, they basically will indicate in quartile regression at 50%, because the simple QREG command indicates a quartile at 50% by default. So if you see here, LSEG or sustainable economic growth is not significant here at 50% quartile. Trade openness is also not significant here. Real growth is significant here, positively and highly significant. And you can also see here, can you hear me, both of you? Hello?